Okay, to solve absolute value equations, we first need a pretty good understanding of what absolute value means. So let's refresh really quick. Absolute value, by definition, is the distance from zero. And we know that distance is always positive. Distance is never negative. So if I say, what is the absolute value of -3? Well, that says how many spaces away from zero is -3? Just 3 spaces. So the absolute value of -3 is 3. I could also say, okay, what's the absolute value of 3? Well, it's also going to be 3. If we choose another number, what's the absolute value of 15? 15. What's the absolute value of -15? Also positive 15. So our result when taking the absolute value of something is going to give us a positive number. Okay, so using that concept of absolute value, when we're solving equations with absolute values, we can end up with more than one possible answer, more than one solution. This is because what's in the absolute value bars, like we just said right here, what's inside the absolute value bars could either be negative or positive. So when we solve them, we have to take into account both of those possibilities. What's inside of there could be a positive number. What's inside of there could be a negative number. So looking at example 84 here, I have the absolute value of x equals 7. This is about the most simple type of absolute value problem equation that we can solve. So if we're just thinking rationally, what values of x could we plug in here that would make this true, that would be a solution? Well, we know that if we take the absolute value of -7, we would get 7. We also know if we take the absolute value of +7, we would get 7. So x could be -7, x could be +7. We have 2 possible solutions. So we're going to use that foundation to solve the rest of these. A couple steps here, because they're not all going to be quite that simple, quite that straightforward. When we're solving absolute value equations, the first thing we're going to do is we're going to isolate the absolute value expression. When I say absolute value expression, I'm talking about the thing inside those absolute value bars. We want that on a side all by itself. Once we do that, we're going to create our 2 cases. We're going to say, okay, maybe what's on the inside is positive, maybe what's on the inside is negative. So let's look at a few of those where we have to isolate our isolate our absolute value first. Okay, here is our absolute value expression. This is what we want to isolate first. So we need to move this +5 to the other side. So we end up with the absolute value of x equals 3. All right, we're going to create our 2 cases when it's only an x inside of here. We're just going to have x could equal +3 and x could equal -3. There's nothing left to solve. This just gives us our solution. So our 2 possible solutions are x equals +3 or x equals -3. Okay, similarly on example 86, let's first identify where our absolute value expression is right here. And that absolute value expression is being multiplied by -4 right now. So if we want to isolate it, we're going to use division to divide by -4. Those cancel, and I'm left with the absolute value of x equals +5. All right, let's create our 2 cases. We're going to take our inside and set it equal to the positive and negative of this. So my x could be +5, or my x could be -5. Those are my 2 solutions. Okay, let's look at one where we have to do more than one step to isolate this. Again, let's identify where is our absolute value expression first. If it helps you, draw a line down your equal sign just to keep your side straight. We've got to get rid of this -4 first, so we're going to add 4 to both sides, and I end up with 5 times the absolute value of x equals 30. Don't forget, a number right in front of it means multiplication. To eliminate that 5, we're going to divide both sides by 5, and now we've isolated our absolute value. We have the absolute value of x equals 6. Once it's isolated, let's create our 2 cases. I'm going to get x could equal +6 and x could equal -6. Okay, example 88. This is the first one we've seen where we have more than just an x inside our absolute values. So let's look at this example. Our absolute value is actually already isolated. It's the only thing on the left side there. So there's no isolating we need to do. We just need to go ahead and create our two cases. On the previous examples, we've only had an x on the inside. Here we have a 2x minus 1 on the inside. So we've got to say, okay, that 2x minus 1 was on the inside could be equal to positive 7, or that 2x minus 1 was on the inside could be equal to negative 7. We're essentially doing the same thing we did in this step. There's just more inside our absolute values than we've seen. So we've got some little two-step equations we need to solve. We can solve both of these. I'm going to add 1, and I get 2x equals 8. If we divide both sides by 2, one of our solutions is x equals 4. If we look at the other one, we're going to do the same process, add 1 to both sides. Here we get 2x equals negative 6. If we divide both sides by 2, x equals negative 3. So our solutions are not always the exact same number, one positive, one negative. And you're going to see that happen when we have something besides just an x inside our absolute value. Okay, looking at example 89, we've got a lot of isolating we need to do here before we can create our two cases. We've got 2 being subtracted, and we've got a 4 being, we've got this 2 right here, and we've got this negative 4 being multiplied by our absolute value. So let's think of what order we want to eliminate those in. I want to get rid of that positive 2 first, so I'm going to subtract 2. What we do to one side, we do to the other, and I'm just going to bring everything else down. Negative 4 times the absolute value of 2x plus 3 equals negative 20. Okay, to get rid of that negative 4, we're going to divide by negative 4. Notice that we never distribute across absolute value bars. We always use division to help us eliminate what's in front. So we end up with the absolute value of 2x plus 3 is equal to positive 5. We've now isolated our absolute value, so I'm going to create two cases. And I've got 2x plus 3 equals 5. 2x plus 3 equals negative 5. Always taking into account both of those. It could equal the positive, could equal the negative. Okay, I'm running out of room here, so I'm going to say the steps and not write everything down. If we subtract 3 from both sides, I'm going to end up with 2x equals 2. If I divide each side by 2, 2 divided by 2, I'm going to get x equals 1 for one of my solutions. If we solve the other one, I'm going to subtract 3 from both sides, and I get 2x equals negative 8. If I divide both sides by 2, I'm going to get x equals negative 4. Okay, looking at example 90, here are my absolute value bars. That's what we want to isolate. So I'm going to subtract 7, subtract 7. I end up with the absolute value of 2x minus 5 equals negative 3. And this should be kind of a red flag in your head right here. If I take the absolute value, no matter what's inside of there, it's impossible for me to get negative 3 as a result. So after we've isolated our absolute value, if we end up with a negative number, we just stop right there. There's no possible solution. So we're going to say there's no solution because absolute value can't be negative. You can write no solution, or you can draw this no solution symbol. All right, and then our last one here where we have an absolute value on both sides. We have it isolated on the left, isolated on the right. So we're just going to go ahead. We still have to create two cases. Be careful how you write this. Our first one's going to be this is set equal to this, just like it's written. 2x minus 7 is equal to 4x plus 6. Okay, we also need to write another equation where this side is equal to the opposite of this side, or the negative of this side. So we have 2x minus 7 equals negative of that right side. If you wanted to do that in one step, you know you're basically just changing your signs. You can, but that just shows you how we're doing this. Okay, we go ahead and solve from here. I'm going to move my x's to the right. And I end up with negative 7 equals 2x plus 6. If we move our 6 over, we get negative 13 equals 2x. If we divide by 2, I'm just going to leave this written as a fraction. One of my solutions is negative 13 halves, negative 13 over 2. Okay, our second possible equation here, we're going to distribute that negative, which just changes all of our signs. We get negative 4x minus 6. If we move our x's to the left side, I'm going to get 6x minus 7 equals negative 6. We add 7 to both sides, and I get 6x equals 1. If I divide by 6, I get x equals 1/6. And that is how we solve absolute value equations. We have to take into account that our answer, what's inside the absolute value, could be a positive, could be a negative.